Okay, so today we're talking about, some factoring difference in sum of cubes in order to factor and solve a problem. So um, if you have something like this, it fits the form of difference of cubes. So what I mean by that is A is x here. That's probably easy to see that A cubed equals x cubed. So your A is really x in this case. I'm even going to write that A is equal to x. And B is not quite as obvious. It helped to know your perfect cubes a little bit. So I'm just going to write those down. So 1 to the third power is 1. 1 times 1 times 1. 2 to the third power is 2 times 2 times 2, which is 8. 3 to the third power is 3 times 3 times 3, which is 27. 4 to the third power is 4 times 4 times 4, which is 64. And the last one I need you to know is this one. 5 to the third power is 5 times 5, which 25 times 5 is 125. And those are really good to know. Just like you probably know your perfect squares up to 13, 1, 4, 9, 16, 25, 36, etc. So you know your perfect squares. It really helps you in math. It helps you to know the first 5. So you don't have to know the first 13, the first 5 perfect cubes, because we use these numbers so often. So now when you see 8, you might think, oh, like 8 is really just 2 to the third power. So B is the cube root of 8, or B, what number cubed is 8? That's 2. So B is equal to 2 here. So if I plug into the formula, A minus B would be x minus 2 times a squared would be x squared plus, I'm just using the form that the plus is in the formula, so I'm just going with the plus sign there. X times 2, or I'm going to write it as 2x plus, again, the formula has a plus sign. B squared is 2 squared, which is 4. So I used, and of course this is equal to 0 because it says equal to 0. So I'm using that to factor it. And now I can set each factor equal to 0. You probably know the solution here. So x equals positive 2. That's a solution. It says to solve it, right? Factors of 4 that add to 2 doesn't factor here. So at this point, you're going to have to use either complete square or maybe quadratic formula. So I'm going to go to quadratic formula. So x equals the opposite of 2 over 2 times 1 plus or minus square root of b squared, which is 4, minus 4 times 1 times c, which is 4. So we get negative 1 plus or minus 4 minus 16 is negative 12. So square root of negative 12 over 2. If you do a prime factorization of 12, that's 2 and 6. That's 2 and 3. There's a pair of 2's with a 3 left over. So this is going to be negative 1 plus or minus. That would be 2 root 3, or 2i root 3, because the negative there, 2i root 3 all over 2, which the 2's cancel, and you get negative 1 plus or minus I root 3. Wow. So it takes a lot of work to do that, but we use the sum of cubes, or that's the difference of cubes, because there's a minus sign between those two perfect cubes. We can use that to factor, and then use the factors to solve the third, the cubic function there. So for sum of cubes, it's almost the same formula. In fact, I'm going to take this formula, I'm going to clone it. I'm going to tell you the difference here. So in a second here, we're going to use the sum of cubes formula. So the sum of cubes formula is the same as difference of cubes, except this is a plus, this is a plus, and this is a minus here. So it's a minus. The last plus is always still the same, it's still a plus. Okay, so to solve this one, first of all, it doesn't look like the right form at all right now. So let's try to get it in the right form. So if you add 27, you get 8x cubed plus 27. If I add 27 to both sides, get that on the other side. So we move that over. And that does look like sum of cubes. I like 8. 8 is a perfect cube, and the base is 2 there. And 64, so what it was, is 4. So 64, no, it's 27. Sorry, 27, so the base is 3 there. 3 to the third is 27. Okay, so my a value, if I want to write it down, it might help you to write it down. So my a value in this case is the cube root of 8x cubed, which is just 2x. The b value is the cube root of 27, which is 3. So I'm going to plug that into my formula. So this is going to be 0 equals 2x minus 3, or sorry, 2x, that's a plus now, plus 3, changed, times, be careful on this one, a squared. So if a is 2x and I'm squaring that, 2x times 2x is actually 4x squared. If I wrote that out, it would be 2x quantity squared. So 4x squared minus, because that's a minus now. It was a plus, now it's a minus. A times b would be 2x times 3, or 6x, plus b squared, which would be 3 squared, which is 9. Okay, we're going to set each factor equals 0, so we get 2x plus 3 equals 0. So 2x equals negative 3, so x equals negative 3 over 2. And this one doesn't really factor, so we're going to do quadratic formula here. So it'd be opposite of b would be 6 over 2 times 4, that's over 8. Square root of b squared would be 36 minus 4 times 4 times 9. Let's see, 4 times 4 is 16. 16 times 9 is 144. So 36, 148, 0, 108. So I have negative 108. So this is 6. 6 over 2 is like 3 over 1. So 3/4 plus or minus square root of negative 108, because it was 36 minus 144, all over 8. Let's see, 108, let's do a prime factorization. That'd be 2 times 54, 2 times 27, 3 times 9, and 3 times 3. So there's a square root, so I'm looking for a pair of 2's, pair of 3's with the 3 left over. So 2 and a 3 comes out. So I get 3/4 plus or minus 6, because that's 2 times 3. I, because of the negative. Square root of 3 is still left over inside. And so the 6 and 8 cancel. That's going to be 3 and 4. So we get 3/4 plus or minus 3i square root of 3 all over 4. That's my other x value. So I get 2 different answers. X equals that. Oh, you get 3 different answers. Sorry, that's a plus or minus. So you get x equals negative 3/2 or x equals that, those 2 answers. Know your perfect cubes. We've already talked about that. So that's going to really help you if you're doing a problem like this. You might just want to stop it and try to do this one on your own. I'll do it real quick. I'm not going to write out the formula, but you need the difference of cubes. A is going to be 5x, b is 3. So the formula is a minus b, so it'd be 5x minus 3 times a squared. Be careful, that's going to be 5x times 5x, which is 25x squared. This is going to be plus, because it's always the opposite of that one, and that's what it is for difference of cubes. A times b would be 5x times 3, or 15x. Plus, always for the last one, that would be b squared, which is 3 squared, which is 9. Okay, so now we've got to set this equal to 0. So 5x minus 3 equals 0. So 5x equals 3. So x equals 3/5. I've got one of my answers. Oh boy, that doesn't look like it factors. So I'm going to do quadratic formula. So this is going to be tough. That's what I'm doing. So negative 15 over 2 times a, or 2 times 25, plus or minus 50 down there. Square root of 15 squared is 225 minus 4 times 25 times 9. Do that off to the side. That's 225 minus 4 times 25 is 100. 225 minus 900. So 900. I have to do it this way. Minus 225 when I do it by hand. 9 minus 2 is 7. 8 minus 2 is 6. So because that other one was negative, it's going to be negative 675. Okay, we'll get to that in a minute. Let's see. This is 5 goes in there 3 times. 5 goes in there 5 times. So we get negative 3/10 plus or minus 675, negative 6 squared root of 675, squared root of negative 675. So that's what's underneath radical. So I know 5 goes in there. 5 goes into 100 20 times. So that'd be 20 times 6 is 120. And 15, 135. Does that sound right? 500, 650, 675. That works. Okay, 5 goes into that. 20 times plus 7, 27 times. I think that works. 3 times 9. 3 times 3. Looking for pairs of numbers since it's a square root. 5 out of 3 comes out. A 3 was left over inside. So 5 times 3 is 15. So I get 15, again, I, because this is negative inside of there. So 15I, square root of, there's still a 3 left over in there. 15 cancels. Wow, this is a lot of work. Divided by 5 is 10. Okay, so we get negative 3/10. Kind of a similar type answer to last time. Plus 3I square root of 3 all over 10. Wow, that's a lot of work. Okay, in this part of your homework, by the way, 49 is actually credit if you want to do it. And we'll spend a little bit of time on this. This won't be the only day we do this kind of stuff. So I want you to graph this in your calculator. So I'm going to show you what I mean. And find any nice rational roots. Rational roots are nice, like decimals don't go on forever. They terminate. They're usually nice fractions or integers, those kinds of nice roots. So let's get our calculator out. Let's graph this and see what happens here. So x cubed, x to the third, minus 6x squared plus 6x. And I'm not going to graph equals 0. You're just graphing the left-hand side of the equation. We want to find the zeros of this graph, I think. So let's see that. I'm going to zoom in just a little bit, just so we have a little bit of separation here between the points. It might be easier for us to do this. I'm just going to hide that so we have more room here. I'm going to change those so you don't have to do all this. Graph will make more sense if we have, oh, this is starting to look like graph paper now. Okay, so you can probably see some, at least like this one looks really nice and rational. So if I use the trace key, menu 5-1, I ruined my nice window there that I had. There we go. So it does look like it crosses 0. So to find any rational root, so I know that one's rational. I'm looking at this one going, 1.27 doesn't look great. I'm guessing it's not rational. I'm going to press enter just to lay down that point and see what the other point is. 4.73 doesn't look great. I'm going to hit escape to get out of that tool. I just want to show you something interesting here. So I know 0 is rational. That's probably going to be the one I use. If I hover over 1.27 and hit the plus sign, it shows me more digits. If I hit the minus sign, it shows me less. Same thing here, plus. You can tell it's rounding off those values. Those are nasty decimals. Those are irrational answers. I don't know what the answers are, the exact irrational answer there, but they're irrational. So the obvious easy choice was 0 because It's an integer. We know that's rational. So I found, and really all I wanted you to find was one rational solution. So x equals 0 is a rational solution. So I'm going to use the quadratic formula to find. So you want to kind of, factor out that value here. In this case, um, you could have also just done this. I mean, you could have just said, well, this is really just x. There's a common factor, the x squared minus 6x plus 6. Right? If you factor out the x, which is what that solution is, x equals 0, that's what causes that x causes that solution at 0. And then we don't know the other two solutions. So use the quadratic formula. So I have a quadratic now. So I'm going to just use that to, like we did on the last problem, right? We'd use the quadratic formula. So opposite of b would be positive 6 over 2 times 1 plus or minus square root of positive 36, because that's b squared, minus 4 times 1 times 6. So I get 3 plus or minus, let's see, 36 minus 24 is square root of 12. I think we did that a minute ago. That's 2 and 6, 2 and 3, or 3 and 2, 3 and 2. I've got a pair of 2's and a 3 left over. So this is going to be 3 plus or minus 2 root 3 all over 2's, and 2's cancel as you get 3 plus or minus square root of 3. Those aren't my only two solutions. My other solution is x equals 0, but we got that one from the graph, or you just factor it out, either one, either way you want to do it, and you kind of find that. Okay, let's try this one. And again, you might just see the nice rational solutions here. If you're paying attention, you go, wait a second, x is part of that, right? X times 3x squared minus 6x minus 9 equals 0. That solution, that's really a factor there, is x equals 0. You get that from the graph if you wanted to, or you could just factor out the x. Becomes easy enough just to do that. Let's try to factor that. I'm not looking promising. Let's go and just do quadratic formula. So x equals the opposite of b, which would be positive 6 over 2 times 3. Plus or minus at 6, square root of. B squared is 36 minus 4 times 3 times negative 9. So we get 1 plus or minus. So that's really 36 plus, because that's double negative there. 12 times 9. 12 times 9. 1 and 9 is 108. So 36 plus 108. So that's 4. 3 is 4, 144. So we get square root of 144. That's nice. Over 6. Well, square root of 144 is 12. So 12 over 6. So we get 1 plus or minus 12 over 6 is 2. That's really two different answers. 1 plus 2 is 3. 1 minus 2 is negative 1. You know what? That did factor. It would have been a lot easier for me if I'd realized that factored. Oh, you know what? Everything. Isn't your life a whole lot easier if you factor out the GCF first? So I should have taken out a 3x there. So if I take out a 3x instead of x, I would get x squared minus 2x minus 3. Oh, are you kidding? So like all that extra work, this is still a factor. You get x equals 0. Now I could just factor this guy, right? So it should be relatively easy factoring x and x, 3 and 1. Bigger number must be negative. That's positive. So solutions are x equals negative 1. Yeah, I think this is easier. And x equals positive 3. So note to self and remember for yourself is always take out the GCF. I just looked at that. Ah, it just looks so tough to factor. But if you take out the right GCF, it makes it so easy to factor. Life is easier when you take out the GCF first. So go ahead and get everything on the same side before we start factoring or anything. So 5x cubed minus 5x squared minus 12x equals 0. You want to take out the x. There is no other GCF, it's just x. 5x squared, this one, minus 5x minus 12. So this solution is x equals 0. That comes from this factor of x. Factors negative 60 to add to 5, or negative 5, let's see. 10 and 6, 5 and 12. I don't think it's going to factor. So I'm just going to do quadratic formula. 5 over 2 times 5 plus or minus square root of 25 minus 4 times 5 times negative 12. So it's going to be adding a number there. So it's going to be 20 times, what's 20 times 12? So 0, 4, 0, 2, so 240. Oh, why did I do that? Okay, 240, so that's 240 plus 240 plus 25. We're adding that, so that's 265. Okay, so this cancels. You get 1/2 plus or minus the square root of 265 all over 10. Prime factorize that. 5, 20, 40, 53. 53, I think that would work. 53 might be prime. Maybe that is just prime. I think that might be your answer. There's a command in here. Let's try this to go home. Graph factor. Factor 53. No, it is prime, right? So that's your answer right there. So those are, you have x equals 0 and these two answers. So using the quadratic formula to find some of those things. That's your lesson for today.